All right, page 63. Reminder, tomorrow you will find a little more about the skills test out. And next week, a couple lessons and we are finishing Unit 8 and sliding into learning about slope. Learning about slope, end of next week. So first question, how many different meals are possible if each meal includes one main course, one side dish, and one drink? I will give you about 30 seconds to come up with a total. Maybe you've seen a problem like this and you already know the answer. I want to give everybody a chance to try it. How many total different meals could you get? Got to get one main course, one side, one drink. I'll give you about 30 seconds to write down what you think the answer is. How many different outcomes you could have. Sure.
Yeah, okay. I'll put down. I want to figure all that out. I got it. That's too much work for my brain.
Brooks.
That's too much work. It's easy.
I kind of guessed about 27.
27.
What?
Georgia.
I guessed and I put down 24.
24.
I did actual math and I got 18.
Actual math.
I got 18. I got 18.
18.
Real math.
All right, now we're going to talk about if it wanted the sample space here, I have to list them, right? Okay, you'd have to list grilled chicken, salad, milk, grilled chicken, salad, juice, grilled chicken, salad, water.
I drew lines.
Okay, you drew lines. So you're going to talk about different ways of showing it. I'm going to give you a little hint to tell you the total number to see if you got it right. Write down the following. Fundamental, counting, principle. The fundamental counting principle says if I take the number of choices for each option and multiply them together, that will give me the total number. Okay? So how many main courses do we have? 3 choices. How many different sides do we have? 2. How many different drinks do we have? 3. So if I multiply those numbers together, each choice, that'll tell me the total number of outcomes. So 3 times 2 times 3 is? Correct answer is 18. Now today, it's going to talk about us keeping track of all possible outcomes. We're going to show different ways. If it would want the sample space, I would have to write out all 18 options. Okay, what are the different ways to do that? Section 2 kind of gives that away. There are 3 different visuals to do. You can make a list, you can make a table, and you can make a tree diagram. Okay, we're going to show one of each here, and then we will try one of each, and then up to you, whichever one you think is best for your personal preference, to please use that one. So if you read number 2, we're going to consider the following experiment. Flipping a coin and rolling a number cube. Number cube just means rolling a die. Elena, Kieran, and Priya each use a different method for finding sample space. Elena writes out a list. She says you're going to get a head. Well, let's talk about how many different options we have first. How many options are there in flipping a coin?
2.
Rolling a die. So a total of 12. 12 different things can happen. Okay, so all the list, table, tree diagram should have 12 options. 12 outcomes. So Elena says you could get a heads then a 1, a heads then a 2, heads then a 3, heads then a 4, and the same thing for tails. Does she have 12 outcomes there?
Yep.
Yes. Okay, look on the next page. Kieran did the same thing, made it a table. Put the coins on the left side, can get a heads or tails on the left. On the top are all the outcomes for the dice, and then you just complete the table. Heads then a 1, heads then a 2, heads then a 3, and so on. Again, does she have 12 outcomes there? Yes. And then here's the tree diagram. Okay, a tree because they consider those things to look like branches. Again, flipping a coin first, my options are heads and then tails. And then after that, I could get a 1 through 6 on the dice. So I could get heads then 1, heads then 2, heads then 3 if you follow the branches. Tails and 1, tails and 2. So 12 outcomes there as well. Number 1, I would just like you to answer your own opinion here. Looking at the 3, what's the same about each method? Write down one thing that you notice is the same. What is one thing that is different? And be sure to explain why. Why does each method produce all the different outcomes without repeating any? And notice there's no repeating. And then answer number 2 as well. Which one do you prefer? What is your personal preference? If you had to choose one of those 3. All right. Brooklyn, what's one thing the same about the 3 options?
All of the numbers add up to 12.
Yeah, they all get the same number of outcomes. Shows the same answers. Anybody got something different than that? Could say they're all visuals. They write down all 12 sample space items. How about different? What's different about them? Colin?
They all look different.
Look different? Absolutely. Appearance? Anybody else have something different? Seems to be the most obvious that they look different. Okay, and the second part there, why do you think you don't get anything that repeats? Like in the table, for instance, why is there only heads and a 1? Why is there no other heads and a 1?
Because there's only 12, so you do each thing once.
You do each thing once, yep. As long as you keep it organized, you should only have one outcome. Absolutely. Personal preference, let's just see. Who prefers the list? No, you're even disgusted with it. All right, so 0. Table. 3, 4, 5, 6, 7 people table. Tree diagram. Everybody else. So I think we have 18 in here currently. That'd be 11. All right. On the next page, we're going to sample a couple of them. And then once we get to the homework and it's asking you, it's your preference. Okay, I'm just going to do one of each type in case you prefer one over the other. First one, let's go tree for this one. Find the sample space. So if it says sample space, what does that mean I need to do? I have to write them out, absolutely. I have to show them all. What am I doing in letter A? Flipping a coin. How many times? Once. How many coins? 3. So how many different outcomes should I come up with?
3.
Okay. First coin, how many options we got?
2.
Second coin, how many options we got?
2.
Third coin, how many options we got?
2.
Would you like to answer that one again?
Yes.
8. That's not 2 times 3. That's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. I should end up with 8 outcomes. Okay, don't forget to use that fundamental counting principle to just know how many answers should I get here. That means my sample space better have 8 of them. So what's the first option when you're flipping Doesn't matter if it's a dime or any coin. Heads or tails, so you're going to write that down first. Now I'm going to branch off of that. My second coin, options are heads or tails. So far I have 4 outcomes. I could get heads, 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 tails. Tails, heads, tails, tails. You see how you follow the branches? I'm guessing that's kind of why they call it the tree diagram. So how many more times do I got to do this? So this is coin number 1. This is coin number 2. One more time. I got to do coin 3. And I branch off 1 more each time. If you have 4 coins, all of a sudden you'd have 16. So it can get quite a bit bigger, right? Times 2 again. So following the top branch, Corbin, following the top branch, I could get, follow this branch. What's this mean? Yeah, I could get 3 heads. Okay, how about if I go heads, heads, and then branch down? Heads, heads, tails. Now I'm going to the second branch. I could get heads, tails, heads, heads, tails, tails. Now I'm on the tails portion. Going to follow the top branch all the way through. Evan, what am I going to get if I follow the top branch all the way through?
Tails, heads, tails.
Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And 3 tails. There is the sample space. Now, the good news is, anytime it would ask you about 3 coins now, you have it. Okay, don't have to make it again. If it asks you for 2 coins, there it is. You have that one done too. If it asks you for 4 coins, you'd have to branch off 1 more time. You'd have 16 of them. But anytime you have 3 coins now, there it is. Okay, don't make it again. Question B. Jared, would you read that one, please?
Mom's closet has a blue shirt, a gray shirt, a white shirt, blue pants, coffee pants, and black pants. Khaki?
Khaki, yep.
Okay. And black pants. You must select 1 shirt and 1 pair of pants to wear for the day.
Okay, so again, how many pairs of, or how many shirts does he have? 3. How many pants?
3.
So that means I should have a total of how many different outfits he could wear? Yeah, 3 times 3. So I need 9. Okay, we already did a tree diagram. Which one do you want to do now?
A chart.
Table?
Yeah.
Okay. So let's put shirts going down. So we have a blue shirt, gray shirt, white shirt. So the top would be pants. Blue, khaki, and black. All right, so I'm just going to make a note that the first letter is going to be shirt color and the second is going to be pants. So I can just leave them in my list. So shirt's going first, so I could wear blue and blue. I could wear a blue shirt and khaki pants. I could wear a blue shirt and black pants. Brenna, can you do the next line for me with the gray shirt?
Gray and blue, gray and khaki, and then gray and black.
Very good. Veronica, can you get my white shirt column?
White and blue, white and khaki, white and black.
Very good. Again, 9 options. Next one, spinning a color and then spinning a number. Let's just do a list on this one. How many options should we have? 20. How'd you get that, Jonas?
4 on the first spinner and 5 on the second spinner, and then I multiplied it.
4 options, 5 options, absolutely. So let's make a list. What color do you want to start with?
White.
Red.
Blue. White.
All right, I could get a red and then a 1. Red, then a red, then a red, then a 4, red, then a 5. I could start with a blue. Blue 1, blue 2, blue 3, blue 4, blue, and a 5. Then do the same thing for white. And green. Again, you only have to list them if it says sample space. If it just says number of outcomes, that made it a lot simpler for you. Just write the outcomes down. Okay, letter D, you pick.
Tree.
Do whatever one you want.
Oh, okay.
So go ahead and do D on your own.
Like it can only land on an hour?
Yep.
Say 12.
12 hours, yep. Haven't made it to daylight savings time apparently yet. Anybody making a list?
Sure.
Anybody making a tree diagram? All right. Tables? All right. That's about similar to what you suggested earlier. Jared, how many outcomes should I be having? Total.
24.
Should be 24. 12 hours on a clock. AM and PM are 2 options. 24. And most of the time it's going to just ask for it and not tell you which method to use, so it is completely up to you.
Oh, that's a lot easier than memory.
Okay, this one, I just made a list. 1 a.m., 1 p.m., 2 a.m., 2 p.m.
We now have to list the answers. Could get.
Those are the answers. I mean, were you writing the times out a little more fancy?
No.
Oh, I mean, you could do that too.
That's a lot.
I did kind of a shortcut. Kellen? Okay. All right, final question. Talking about sandwiches. This is always an interesting one. The next time you walk in the subway and you go, how many possibilities could I possibly get? Okay, well, this sandwich shop, you can only choose, obviously, one kind of bread, 1 protein, 1 cheese, 2 veggies. How many different sandwiches could you get? Explain your reasoning. Here's a big key for us right now. We don't even have to write them all out, so that's pretty nice. So how many different breads do we have, Jared?
3,
Proteins,
3, 4,
cheese.
4.
You might say, well, there's only 3 cheeses, but you do have the option to get no cheese at this sandwich shop there as well. Veggies, 5. So just 3 breads, 4 proteins, 4 cheeses, 5 veggies. That is a total of, go ahead, Jared.
240 choices.
240 different options of sandwiches.
That's a lot.
That is a lot. Question number 2. Autumn, Okay.
For question number 2, I have a question on that.
Yes.
Since you could get like 2 vegetables.
Oh, yes.
Couldn't you?
2 veggies.
So that would mean it's 10.
Or you could get all of them. Multiply all that by 2,000.
So how many choices do you have for your second veggie?
4.
Okay, pick a veggie.
Lettuce.
Could you get double lettuce, you think?
Yeah.
Yeah, so that's still 5 choices. So whatever Jared got, take it times 5 more. Good catch, Autumn. 2 veggies.
But what if we have 3 veggies?
Then you take it times 5 again.
1,200.
1,200.
I'll take everything on there.
That is a drastic difference when you can get 2 veggies. Question, good catch, Autumn. Question number 2. Sophia, would you read that one, please? Number 2.
Andre knows he wants a sandwich that has ham, lettuce, and tomatoes on it. He doesn't care about the type of bread or cheese. How many different sandwiches would make Andre happy?
Okay.
What will make little Timmy happy?
It has to have ham, lettuce, and tomatoes. Why don't you take a minute and see if you can guess on that one? He doesn't care about the bread. Doesn't care about cheese. Jared?
12 sandwiches.
How'd you get that, Jared?
I took the 3 breads times the 4 proteins because he said that he wanted cheese and vegetables, so I didn't add them and only took the bread and protein.
Yeah, because he's picking ham, he's picking lettuce, and he's picking tomatoes, so those are already chosen for you, so 12 different sandwiches would make him happy. That's exactly right, Jared. If a sandwich is made completely at random, now tying this together with what we did yesterday, what's the probability that Andre will be happy with his sandwich? What's that?
You better look.
Corbin, go ahead. How'd you get that?
1,200 divided by 12.
Yeah, 12 make him happy out of the 1,200 he found from problem 1, and then he reduce it. And so he's got a 1% chance of being happy randomly with his sandwich. Is that a chance you're willing to take, Andre? All right.
Andre is picky.
Final question. Are you ready for more? You need to come up with a situation that has 3 different parts to it that you would get 24 as an answer. Whatever you want. It could be more on the sandwiches. It could be a bunch of different things, I guess. Georgia, give me something that has 2 options. Anything. Give me something we could do that has 2 options.
What do you mean, like sandwiches, like something like that?
Sure. You could even do easier than sandwiches. You could do what? Froyo? Picking yogurt.
Yeah, so then you can put your
What are the 2 kinds of yogurt then?
vanilla. Wait, no, it's not vanilla. It's strawberry and Hawaiian.
Hawaiian. All right. You get 2 types of yogurt.
I'm not hungry.
I mean, I could have just said flip a coin, but we can choose froyo. Okay? Josh, what else could I put on my froyo?
Granola, more yogurt, and
Extra yogurt
So is Hawaiian yogurt.
sugar.
and sugar. Yikes.
Gummy bears.
All right, so right now I have what? 6. So what number needs to go here? 4. So in your froyo, you can get it in a cone, a dish,
A plate.
A plate,
A bucket and a cup.
and scooped right into your hand. You got 4 options. Okay?
I would do the hand one.
Yeah. That was interesting.
Now I'm craving froyo.
Froyo. Well, I hope you get Hawaiian with extra yogurt scooped right on your hand.
Love to, but then it got voiced by Fargo, and I was so mad.
All right. The summary. Just a good page on 67 to reference if you prefer tree, list, or table. That's another visual example there for you. Take a look at the homework. Starting on page 68. Okay, he has a tree diagram. He's planning a birthday party. He's got 3 different themes he could do at 2 locations and 3 options for days. It's asking you for questions A through E. A through E. Remember, if it says outcomes, you can list them. If it says sample space, you have to write them all out. Know the difference between the 2. Okay, question number 2 on the next page. Write out the sample space and tell how many outcomes there are. You got to do both. Okay, I would prefer to do the first one first, how many outcomes, so then I know what my sample space looks like if I'm missing any. Okay, so underline those 2 things so you don't forget either one of those on question 2. And question number 3 and 4 on the back. First one is estimate the probability that 3 or more kicks are made based on the following trials. And question number 4, it's asking you about the probability of drawing a green marble. Okay, Andre takes his turn at drawing, so does Jada, and so does Noah. Okay, be sure to explain why on that problem. How did you get that? Why does it make sense?